Welcome back, everyone. Carbon capture technologies can provide impactful tools for decarbonization. So in our final panel of the day, we are going to deep dive to take a look at carbon capture technologies, the opportunities and challenges and risks that both nature-based as well as tech capture solutions can bring. We're also going to explore the future of these applications and the role that startups will play in creating and implementing them. As a host for this session, I'd like to warmly welcome Jasmine Lin, who is the co-lead of Wire International Women in Renewable Energy, and is going to host this discussion. Thanks so much for being with us today, Jasmine. Over to you.
Hi, thank you so much. Big hello from Toronto, Canada. I'm Jasmine. I'm with Women in Renewable Energy. We are a global nonprofit, and we have a mission to accelerate and empower women in the clean energy transition. Today, I'll be moderating the panel CO2 for you, so welcome. This panel is focused on carbon capture and usage technology in different global markets. Today, we are discussing ways that cutting-edge companies are using captured CO2 emissions and feeding them back into our economy in a sustainable way. We will be looking at the emergence of renewable carbon source applications such as crop growth, sustainable fuel synthesis, and carbon-based materials. We know globally that in order to meet our global net zero targets, carbon capture has a significant role to play. But how can we accelerate the widespread growth and adoption while encouraging decarbonization of the world's highest emitting sectors? In this panel, we will deep dive into these technologies, look at opportunities, challenges, and risks of both nature-based and technology-based capture solutions. And we will explore the future of carbon capture applications and the role that startups play. Today, I have a wonderful, very knowledgeable panel. We have Cristel Lambton, the Technical Director of Northern Lights, Simon Bager, the Chief Sustainability Officer and co-founder of Klimate, and Henrietta Moon, the CEO and co-founder of Carboculture. I will let them introduce themselves. Could you please, each panelist, provide a brief introduction of yourselves, what your company does, and specifically the carbon technology that you use? Simon, we'll start with you.
Thank you so much. And thanks for having me here. It's a great pleasure and a great honor. My name is Simon Bager. I'm the co-founder and chief sustainability officer at Klimate. We're a broker platform for carbon removal, looking both at nature-based and technological solutions. And we work with a number of different technology providers and carbon removal companies across Europe and especially in our Scandinavian market. And we're based out of Copenhagen, Denmark. Thanks.
Henrietta?
Hello, everybody. I'm the CEO and co-founder of Carboculture, and we do carbon removal. And how we do that is that plants capture carbon dioxide by photosynthesis, but if they were left on their own, they would quickly decompose. So plants capture the carbon, and then we convert it into a stable form for 1,000 years. So that it's permanently stored. So basically, our technology is ultra-rapid carbon conversion that makes biocarbon or near pure carbon out of the plant biomass. And in this way, we capture the carbon for a very long time. We also produce excess renewable heat. So the process itself does not require a lot of energy, but instead and thirdly, actual addition to the carbon removal credits. And we're based out of Helsinki, but we have operations in the US as well.
Thank you. And now, Cristel.
Hello, I hope you can hear me. Can you hear me?
Yeah.
Yes. Thank you. So my name is Cristel Lambton. I'm sorry I missed everything which has been said before. I'm a technical director of the Northern Light joint venture. Northern Light is a joint venture between three energy companies, which are Equinor, Shell, and Total Energies, and it represents the transport and storage component of the Norway's Longship project, which is a demonstration project across different value chains to store to capture, transport, and store CO2 permanently. Northern Light has an ambition to provide carbon storage as a service, and it's open to the European industry. What we do is deliver carbon storage as a service to companies across Europe, and we are developing the world's first cross-border, open-source CO2 transport and storage network to hopefully help Europe's industrial emitters to reduce their emissions further by providing a flexible ship-based transport and permanent geological storage for captured CO2 offshore Norway.
Thank you, everyone, for those glowing introductions and for bringing us up to date on the technologies that you use. So our first question is a general introduction question. As we all know, the recent IPCC report that came out says that we are headed down the path to not meet our global emission reduction goals to reduce global warming to 1.5 degrees Celsius. How does climate policy and carbon capture technology play a role in us meeting our net zero goals? And if you have any examples from projects that you're working on that have significantly captured carbon, please do speak to them very briefly. Thank you.
I could start by saying that even though, as a carbon removal company CEO, that's the majority of work is in the emission reduction, and that's what absolutely needs to happen and is imperative that happens alongside carbon. So carbon removal can perhaps get us 1/3 of the way of the Paris Agreement, if even that, and the rest has to be emission reduction. So that has to be super, super clear in the agenda. And for removal, why is it so important? Both McKinsey, I guess based on the IPCC reports and so forth, estimate that global carbon removal capacity should be at 2 billion tons by 2030 and about 10 billion tons by 2050. And today the capacity is somewhere around 30 million tons perhaps. So we have a long, long way to go in terms of and these are to avoid catastrophic climate change. So we have a long way to go. And also remember that here we're talking about permanent carbon storage. So really not capturing CO2 and then making a fizzy drink out of it or something else, but actually making sure that the CO2 is locked away and it's not in years. So that's what in the removal space. And we welcome all sorts of innovations because no one technology is gonna do all needed alone.
And I think thank you. And I absolutely agree with what Henrietta just said. And I think coming from the position of the broker that is placed in between the technology providers and a lot of the clients, and also, of course, interacting with governments and the broader policy framework, it's absolutely clear we need to bet on more than just one technology. We're not going to pick, the technology for this. It's going to be, direct air capture, biosolutions such as what Henrietta is working on. It's also going to be a lot of nature-based solutions. There are a lot of hybrid solutions that fall a little bit in between, relying on nature for part of it and technology for locking away the carbon. For example, what Carboculture does. And we really need, we sometimes liken it to say, you need 1,000 bets on 1,000 horses. We need to do all this at once. At the same time, we need to reduce our emissions drastically. And as Henrietta was saying, the IPCC report is quite clear. And what we also say to the companies we work with is, of course, you need to be able to measure what you do. You need to reduce already as much as you can. And then you need to remove the rest. And you can remove in a lot of different ways. And you can remove ways that are sometimes a little bit faster, but doesn't necessarily remove the carbon from the atmosphere for as long a time as other solutions. And that's why we think that there's a need to develop multiple solutions at once. So from a technology perspective, there are certain things that are quite mature. Various forms of pyrolysis that lock away biomass in an inorganic form that stores it for hundreds of thousands of years. It's fairly developed, but not that developed. And then you have at the other end direct air capture, which is growing, but it's still a very, very minuscule technology from a global perspective. And we need to look at all of that at the same time. And I think this is where the Northern Lights projects and all those things come in. We need to capture some of the emissions that come from various point sources, such as power plants, cement production, etc., and lock that carbon away as well to basically prevent any more emissions from entering the atmosphere. So it really isn't betting on one thing. It's trying to do a lot of things at once, and that is what makes it so difficult, but also really interesting and provides a lot of opportunities.
And to bounce back on what, thank you. To bounce back on what I said, to reach the net zero greenhouse emission by 2050, carbon capture and storage is only, as we said, one of the tools to be used and one of the technology to be used. However, it is an important one because usually it addresses itself to industries which have hard to abate CO2 emissions, which by their processes emit CO2 and are even after a transition to renewable will still emit CO2. And we cite, for example, cement, steel, waste to energy. Those are industries which will need definitely carbon capture and storage because their processes themselves emit CO2. And even if they were transitioning to cleaner energy, their processes will always be an issue. So there are some research on how they could adapt those processes. But I think that the main thing with CCS is it will be key for this industrial transition towards the net zero emission. But it will also help, for example, as a core of the European economy, help keeping those jobs which are related to those industry still trying to achieve a climate neutrality. So there's a major transformation towards energy intensive industry where CCS is an important tool, but as we said, not the only one.
Thank you, everyone. And now we'll segue into our next question. We spoke about different technologies, different methods of capturing carbon. So how can nature-based solutions and then technology-based solutions complement each other and really help to bring the technology to scale? And what are some advantages and disadvantages of nature-based versus technology-based? If we could start with you this time, Cristel.
Yeah. So as we said, to reach net zero, we need negative emission from both nature-based and technology-based, like CO2 storage, and they will both be essential. The storage of CO2, which is captured directly from the air, and bio-CCS, so direct air capture and bio-CCS, will be important, but in a smaller, they are for the time being on a smaller scale. We will need to store the CO2 from those hard to abate industries, as mentioned before, and both NBS and nature-based solution and technical-based solution will be able to offer certificate for negative emission, and it's quite an important aspect of to see in the picture. We will also need some verification and certification standard for those which should be developed. In terms of advantage and disadvantage, I think at the moment the issue is the scale, and it's actually applies for both CCS and nature-based solution. We need to develop and roll out those solutions, and we need to do it fast. And it's the difficult part is to go fast enough to make a difference and to reach the ambition which are set by the various states. And that's the hardest part, because things takes time. As long as you want to do some permanent geological storage, it takes quite a lot of time to develop those storage. It's a full maturation process which needs to be performed, and that is time consuming. And in a way, we're trying to keep up with the demand, but it will have to be accelerated in the next decades.
Yeah, so I can continue from that. So I see two direct links. So first of all, we kind of bridge the natural carbon sequestration potential and then the technology bit. So globally, all our biosphere already draws down hundreds of gigatons of carbon dioxide annually. So this huge carbon cycle that we have already happening for us can be tapped into, and that's why we decided to choose that route, because we thought that it's the most elegant solution to actually getting the carbon down from the atmosphere. But of course, if you have that in biomass, it will only store it when it's alive. So if you think of a forest, it will not grow 10 times in height once it reaches maturity, or so forth. So you actually need to couple it with technologies such as our technology, where we can take some of that biomass that would be otherwise destined to rot or be incinerated, such as, you know, any kind of food production residues that are not used for animal feed or calorific value. And then we can turn that into a stable form of carbon and start locking it away while biomass keeps growing in the same land area. So I think it's a brilliant tool to actually put these two things together, and they can be far greater than each other with these two pieces. And the same goes if we look at just today. For us, for example, as a biocarbon company or biochar company, we produce vast amounts of renewable heat as a side product. And now there are different kinds of carbon capture technologies that need a lot of energy to be able to function, such as direct air capture. So we could actually be a provider of that heat energy to a direct air capture plant, which would allow them to locate in a new location that otherwise they were geographically constricted to hotspots of a lot of plentiful renewable energy. So there's a lot of things that we can do together, and I do feel that we will find these solutions of reutilizing gases for alternative protein production, or using the heat energy for another system, or something similar. So I think this is the decade of solutions, and I think there's a lot to do with biology and the millions of years of work that the biology has already done for us.
I absolutely agree with what has been said so far. And I think one of the things that is perhaps important to bring into this context is also the issue of scale. I mean, it is right that technology can provide a lot, but at the moment, nature-based solutions are just more widespread, and there are a lot more credits available in the market from nature-based solutions. But I really do believe that we need to combine these efforts. We need to combine what nature can provide best and what technology can provide best. And Henrietta brought up the concept of the biological cycle, and that really is important. We have the global carbon cycle and how that stores away a lot of carbon. So we also need to look at, for example, protecting our forests, which is a way of preventing a lot of emissions from happening in the first place. We need, of course, to also grow more forests and utilize other forms of nature-based solutions to lock away carbon. But then while we do that, we need to think also about looking into the geological cycle. So where do we store away this carbon in a way that it doesn't become available in the atmosphere again in 30 years' time, which is the problem of some of these nature-based solutions, that the permanence is relatively short. And then an aspect we haven't really discussed is also how additional are some of these solutions? How much do we actually store away more carbon than would have otherwise been stored away in the basic biological cycle already? And that's the problem of some of these nature-based solutions, is basically proving that it's having an additional effect on what would have happened, in the absence of some of these projects. So I think there is a lot of opportunities for tapping into both these technical solutions to basically make nature even better and complement what nature does best, but also to think about how we can think about this in a more circular perspective, which is a little bit what Henrietta brings up with this discussion of, can we locate a direct air capture plant next to a biochar facility, for example? Or can we think about utilizing old oil wells for putting in oil that is artificially made from biomass material, which would have otherwise gone to waste? And all of these different concepts that really try to bring in. So I think there is a lot of options for solutions, and that's also why when we think of this from a broker perspective, it's really about it's not betting on one. It's trying to say, okay, there are nature-based solutions, there are technological solutions, and there are these kind of hybrid solutions that fall a little bit in between. And I think in the next decade or so, we really need to focus a lot on scaling the technologies that have potential, at the same time as utilizing the nature-based solutions that we can do right away.
Amazing. Thank you, everyone. And we as we discuss disadvantages and obstacles, that brings us to our next question, which is, what is the biggest obstacle or some of the biggest obstacle that you've encountered to full-scale carbon capture? And can we perhaps touch on not the technical side, but also the finance side of scaled up carbon capture installations?
Yeah, I think maybe I'd like to kick off actually, since we sit a little bit in between, and I know both of the other two women here on the panel, they are more the technology providers, and I think from a perspective of where we sit, of course, finance is a big issue. You know, the cost of some of these technologies is fairly high on a per ton of CO2 emissions basis, and that is of course something that needs to be brought down. It sits currently at a level where a lot of governments or private companies do not have the capacity to invest in these solutions. So, of course, it requires in some places it requires subsidies of various kind, or basically basic research and innovation to bring down the cost of this. Of course, also economies of scale will hopefully bring down the cost of this. So I think what we really hope from our side is that by tapping into the solutions that some of these technologies provide, we can help bring down the cost of this to a level where, you know, the market can take over and facilitate the growth of these solutions, because it becomes, you know, the demand will help drive this. But at the moment, we are at a place where a lot of these solutions are prohibitively expensive, and I think direct air capture is a case in point here. So that's also why it still has a very, very low overall market share compared to, for example, nature-based solutions that has a substantially lower cost, but also, of course, provide a different type of carbon capture.
Yeah, I think if there are some government people listening, there's definitely a few things that I could say from a small company developer. So basically, it's critical that we get these first facilities up and running with government-backed loans. There is no private project developer that's going to touch a first facility when it's a new technology. Even if it's like semi-established, it'll never be established enough for the actual project financiers. So the first facilities are typically made on equity that the company has to provide or come up with. So there, I'd really urge governments, local governments as well, and other providers, perhaps family offices or somebody else, to be able to give longer term, low interest rate loans to companies when they start building their first facilities. And those are critical to just showcase that the technology works, that you get enough operating hours, et cetera, and then you can tap into the vast amounts of funding that is out there for green projects and ESG projects. But this kind of like gap is something that we need to desperately bridge if we want to get anywhere near our targets in the next decade. And this doesn't mean something crazy. This means that you could guarantee project costs, loans for the project cost up to whatever you're comfortable with. Maybe it's 50%, maybe it's 75%, and the company would need to come up with the rest from equity. That's also fine, but something needs to move there. There's a lot of climate funds and climate pledges, but they don't seem yet to have a lot of projects working. So that's a problem. And especially in Europe, like, we want to have these green technologies come online here so that we can build huge global companies solving these problems. So that's something beneficial for the whole region. And, you know, year-long EU grants or something are not the solution to actually rapidly getting these things to market. So I think there's a lot to do with the funding domain that really needs to be considered again. And those countries that move rapidly in this will also start to actually gather that climate technology knowledge into their country. So I think there's a lot of advantages as well to start with.
I think if I take the example of Northern Light, I see that developing a brand new value chain and infrastructure for carbon capture and storage, for the time being, could only be developed through cooperation between the government and the companies and the industrial. In the longer term, of course, we expect the cost of development and execution of CCS to go down. and the cost for the industry to emit CO2 to go up, because that's the main issue at the moment. The ETS level is too low to encourage emitters to actually do work and be front runners into capturing the CO2. It's actually cheaper to emit your CO2 as per today. So we expect that when those cost level for the industry to emit the CO2 will start moving up, there will be more realization of CCS project and without subsidies. However, as we mentioned, as has been mentioned, subsidies per today are vital for those front runners, and some industries have decided to be those front runners and to show that it can be done. They also know that subsidies will not last forever, so they want to be part of that first wave. But there are the need for some incentive as well from each state and from the EU. And with the discussion we have, we're in dialogue with several industrial companies which are across Europe, which are willing to be those front runners. And at the moment, it's a subsidy typical system, as we see that so our new solution needs to be developed to encourage those industrial to actually work on those projects.
Yeah, and I think it's worth adding to that excellent point is that the more industries come under regulation, that they actually have to meet certain emitting targets, the more industries will start thinking about how do we actually reduce our emissions before we have to pay these dramatic costs, and start thinking about as well what kind of solutions can they use for the carbon removal or carbon offsetting. So I think when companies notice that they're starting to think about legislating their domains, then they will start thinking about, are we going to be profitable in 2030 or 2035 if these new legislation come on board? And that's amazing. And that's exactly what legislation should be driving, is a cleaner economy, and also these new solutions to be able to come to market.
And I think also on that point that was raised by Cristel is, she mentioned the ETS, and that's absolutely an important vehicle, especially in Europe, for a lot of the larger polluting industries. But there's also a voluntary carbon market, and at the moment they're operating quite distinctly in two silos. And there's a need to think about how we make sure that the developments and the policies we put in place are actually fostering both of these, so that there's the regulation that takes place on the one hand and then the voluntary market on the others. And both are needed in terms of driving some of these industries forward and bringing down the cost. And at the moment, a lot of the carbon removal that happens is driven by a lot of voluntary commitments from companies, but there's also a need to bring the government regulation into a place where it can contribute to help some of these technologies scale and reduce the cost.
Sounds like this is a very hot topic, and thank you for the different perspectives and really bringing into the fact that this is, again, just like reducing emissions is not a one solution kind of problem. Finding finances is not a one solution kind of problem either. We do need action from governments and private corporations and legislation. So I think it's great, the points that everyone brought up. Thank you. And we talked a bit, I think Cristel mentioned the workforce. And so my next question is, how can we train or prepare the workforce to have the people power, not manpower, because it is 2021. How can we have the people power that we need to bring carbon capture to scale and to meet our net zero targets?
It's a good question, and I think, I mean, obviously there's an engineering and kind of STEM aspect to this, that we need people who can actually develop and work with some of these solutions. But that is only part of the equation, or that's one side of things, is that we need, of course, to develop these technologies, and absolutely engineering and innovation and science and so forth is really important in trying to figure out how do we capture, lock away, etc., store this carbon. But we also need literacy on sustainability and the need for reducing climate change on the other end. We need a lot of companies that are not necessarily the ones delivering these technologies, but who will themselves have to reduce their emissions to be more aware about the issues posed by climate change and the need for measuring and reducing their own emissions. So I think that's also where we can quite easily do a lot of things. We can ask of the companies that we work with that they try to be aware of this, that they really measure their emissions, that they try to do something about reducing these emissions, and then whatever they can't reduce, that they do actually try to do something to remove those emissions. So I think that is one place where, I think there should be a sustainability officer, and almost any company of any size, you should have a sustainability officer that is working on some of these aspects. And of course, we can also, legislation can do something here. It doesn't have to be driven by voluntary efforts, all of it, but reporting requirements for larger companies that they actually become aware of what their emissions are is something that could help drive this. And of course, we need to educate the younger generation about some of this, and I think they're doing a much better job already than we are. I already feel old as a semi-old millennial, and the younger generation is already much more aware about these problems, and I think they will naturally, when they enter companies, try to ask that we shift towards this agenda and do something about it also internally in the companies.
Yeah, there's been an influx. Oh, sorry. There's been an influx of people who want to work at least in climate tech. So definitely we're seeing a lot of people wanting to change from whatever they were doing before, perhaps other technology companies, taking pay cuts, ready to work for earlier stage companies. People want, they can see that we are in a crisis and they want some meaning into their life. So definitely there is a big influx of people who are ready to make the leap, even with, by putting, even by taking a financial hit on the leap themselves. And another point is that a lot of these things are novel technologies that haven't existed, or perhaps have existed but not been implemented into commercial scale for more than a few years, perhaps a decade. So we really just need brave people who are ready to be really, really open and hungry at learning how to deploy new technologies and how to work in new markets with new products. And that's something that I don't know if we have time to go through multiple rounds of university education. We need people today to show up and do that work.
Yeah, and there is something which we see gradually coming, is the fact that the pathway towards climate neutrality is going to bring a major transformation of the industry as we know it, and especially the energy intensive industries, and that is the core of the European economy as such. For these sectors, CCS among others is in a way the lowest cost route to decarbonization. And I don't think we need necessarily to train new people right away, because as you mentioned, it will take time. But there's a lot of knowledge out there which can be reused to this. You can take simple plants and look into the process and implement, for example, direct air capture or carbon capture. It's not necessarily that you need to train completely new personnel with completely new ideas and new theory. You can reuse a lot of what is already known to implement those methods. If again, I'm going to take the example because that's the one I know the best, but for transport and permanent storage, we are using competence that we have in the oil and gas industry, because that's a core business, and that's what we know how to do, transporting and storing. Normally we extract, but storing is in a way the opposite phenomenon of extracting. So we use a lot of our core competencies to actually bring something new to the debate. And if you apply to all this method to existing industrial processes, power plants and so on, with CCS you could secure those jobs, and by also creating new ones. And you can also secure the industry competitiveness in Europe, for example, compared to international markets, depending how quickly they develop. And still you will be able to deliver sustainable growth. So I don't think there's a need for a brand new workforce and a full shift. I think reusing what we already have in those core competence in those companies would definitely be the best way to do so. And then, of course, afterwards, gradually get new new ideas and newly trained people with developing those new ideas, but utilizing the core competence, the job that we have there, and trying to do everything we can to preserve them and transitioning to net zero. I think it's the key for the next for this, to try to solve this climate issue.
Okay, I think there's been a great diversity of answers, and we are coming in at about 5 minutes left of the panel. So at this time, I will open the floor for the panelists to cover anything that they would like to touch on before we end. And just a reminder, we did speak about the finance side of obstacles towards scaling up. We talked about nature-based solutions versus or integrated with technology-based solutions. And we discussed the workforce and scaling up technology and people for carbon capture. So I'll open the floor.
I can start briefly, maybe. We talk a lot about renewable energy, and we all know the importance of those energies like wind and solar. We know they're playing an important role in producing cleaner electricity, typically, for example. But those clean energy alone are not going to be able to develop a net zero energy system. So CCS is one of the levers, as we saw. It's one of the tools that we have available to us. The technology is known. We have used CCS since the 80s, so it's nothing new. It's just that we need to develop a new market. And this market at the moment is taking time to develop because, as we've seen, the incentive for the front runners to be able to start capturing those emissions are not quite in place there. So I would like also, like you did earlier on, try to launch this message that the incentives need to be there for the first runners, and we need to accelerate this development. If we want to really make a difference with CCS, things have to accelerate drastically. It takes time to develop. It takes time to establish those new infrastructures and those new networks, and we are a bit, time is the essence here. We don't have so much time. So it's really important that we all try to bring this to a new speed in a way, because only with a full rollout, we will be able to reduce the cost. And the costs at the moment are really not a showstopper, but they are slowing the development down. But it's a full rollout which will allow us to reduce those costs and be able to make CCS the tool that it needs to be for helping reaching a net zero ambition. Thank you.
Henrietta, you're muted.
Classic 2021. Thanks for having me on this panel. And I'd like to mention that Carboculture is recruiting. We're hiring in both Europe and the US. So go over to our LinkedIn or our website if you're interested in carbon removal permanently. And yeah, thanks everybody.
Yeah, thanks, and thank you to all of you for having me here on the panel. And I think, lastly, I think the point I want to stress is that one of the things at the moment is we really need to scale supply. There is a demand for solutions that remove carbon, both from the private industry, from the voluntary markets, and also from governments. But actually, supply is of the essence at the moment. I mean, the supply is what is squeezed. We need to come up with ways of scaling what is already there and what can be done. And we can do that through, incentives, regulation, etc. But we can also do that through innovation. And we really need to come up with a lot of ways of trying to figure out how do we scale the supply of these various technologies. And whether it's CCS and the very high-tech solutions like direct air capture, the more hybrid solutions like Carboculture and provides like biochar and so forth, or whether it's these nature-based solutions. We really need to focus on scaling these because we need to remove 10 billion tons by 2050. And with the current trajectory, we're not getting there. So that's basically also what we're helping doing in Climate. And I think what everyone in this space is working on is trying to say, how do we provide the most solutions, the best solutions in the shortest amount of time? And yeah, thank you for having me here. It was a great pleasure.
Okay, and that's the end of our session. Thank you to all the panelists. And thank you to Startup Energy Transition for having us here today.
Thank you so much to you, Jasmine, and to your panelists for that super insightful discussion. With that, we have already reached the end of our day program, and it's time for the closing remarks.